Today we're going to build a foldable on machines and mechanical advantage, force, and what we're going to do is take our piece of paper and fold it in half, fold it in half hamburger, and open it up, and it's going to make this middle line right here. And then fold the top half to just above that middle line and the bottom half to just above that little middle line, not right at the middle line. The top half you're going to cut into 4 tabs, and the bottom half you're going to cut into 3 tabs. Now, the bottom half we're going to discuss machines, and the top half is actually going to be broken into 2 parts. Okay. This half is going to be mechanical advantage, and this half is going to be forces. So let's go ahead and put our labels here. So machines are going to be right here. And what we're going to say about machines is that they make work easier by changing Okay, so this is going to go right underneath machines. Now we haven't opened the flaps. Our flaps are closed and down. Okay, they're just laying flat against the paper. This is the space that we have left. Now this topic over here is going to be about mechanical advantage. I'm going to change the font, just the color, just to make it a little different. That's going to go right here. I'm going to shrink this down a little bit so it'll fit. And then in here we have text on that say forces. We'll change that to a different color. That's going to fit right in here. So those are our 3 parts that we're going to discuss. When we talk about mechanical advantage, there are actually 2 parts. There's actual mechanical advantage, and there's ideal mechanical advantage. So we have actual, and I'll just use MA for mechanical advantage, and we have ideal mechanical advantage. For forces, we have input. These go on the top of the flaps. Haven't opened the flaps up yet. And we have output. Now, there are 3 ways we make machines make work easier. This is going to be flap number 1, this is going to be the second way, and this is going to be the third way that machines make work easier. So now we're actually going to open up our foldable, and we're going to look into these first 2 mechanical advantage flaps. So right now open up your first 2 mechanical advantage flaps, your actual and ideal, and we're going to write inside. So here you have the flaps open. Okay. And you have down here where you wrote the words mechanical advantage, or I typed in mechanical advantage. These are already there. They're written in green on my previous page. So, on the flap, we're going to remind ourselves that this flap is discussing actual mechanical advantage, and this flap is discussing ideal mechanical advantage. When we're talking about actual mechanical advantage, and this is where the flap folds, Okay, so right here when we're talking about actual mechanical advantage, we're talking about the mechanical advantage of a machine in a real situation. When we're talking about ideal mechanical advantage, this is what they sell you a lot in car dealerships. When they tell you that the gas mileage is going to be 36 miles to the gallon, that's in an ideal situation. Unfortunately, you don't always get those numbers because you live in an actual real world, in real world situations. But your ideal is the mechanical advantage of a machine without friction. It's pretty much not going to happen in the in real world. We have air. We know air resistance is a type of friction, so we always have friction. So now let's look on the second half when we talked about forces. We have input force and output force. If you didn't get all this down, make sure you press pause or back. If it goes too far, you can always go back. So the second half, you have this portion from the mechanical advantage side. Have a flap. Your flaps are now open. And this is the fold line where the flaps open up. Then you have your midway line. And right here you wrote, or I typed, forces. Okay? So let's remind ourselves that this flap is input and this flap is output. Right? So if we have a machine, I'm putting this right here at that split point. Okay, this is the in, and this is the out. So input is the force that you exert on the machine. What you put into it. And output is the force exerted by the machine. So if I'm using a shovel, the force I put into the machine to use the shovel is the input force. What the shovel gives me, that's my output force. If you're wondering why a shovel is considered a machine, the reason is because it's a lever, and we're talking about simple machines. So now we're going to look at the bottom half, and we're going to see how machines make work easier by changing things. So this is the midway line, and you have 3 flaps that you need to open down at the bottom. Okay, this is the fold line for the 3 flaps. And we wrote, or we typed up here, machines make work easier by ... Okay, so what do? They do one of 3 things. They can change, by changing. So they make work easier by changing how much force you need. So in this case, a good example is I could take a piano and lift it up onto the stage straight up, and that would require a whole lot of newtons of force to get it straight up that stage. Or I could use a ramp, and I can use less newtons of force, though I have to go a longer distance because I have to go to the end of the ramp and push it slowly up the ramp. But I get to use less force. And so the ramp is a simple machine that helps to adjust the force that I need. So I'm just going to draw a picture right here of a ramp or an inclined plane. That's what we would call it. And my little truck. Going up the ramp. Okay. It could also change the distance you need the force. So it can make work easier by changing the distance, how far, the distance you need the force. A baseball bat is a simple machine. It's a lever. Because the baseball bat extends from my arm, I apply a great force, but I don't have to apply it very far. The extension of the bat goes further than my hands move. And so you can see that the machine made work easier for me because my hands only moved a short distance, but the end of the bat moved way further. So I'm just going to draw, since I'm not very good drawing a baseball bat, I'm going to draw a little guy here. Okay. And he has a fan. He's holding a fan in his hand. Like a little paper fan because he's hot. And though his hands are only moving a little distance, the fan up top is moving a greater distance. So the distance you need the force is changed by a machine. My last one is machines make work easier by changing the direction from your force. Or the direction of your force. Okay, once again, I'm not an artist, so I'm going to draw this the best way I can. Let's say that I have a sail, and I need to open the sail up on a sailboat. I could grab all the cloth material and climb up the pole with it, which would take a lot of force. Or I could use a pulley system, and I can just pull down on the pulley system and the sail rises. So the sail has to still get up the same distance to the top of the pole. So I'm not changing the distance, I'm not changing the force I need. It still requires that much force. I'm just changing how much force I apply over a certain distance. So when I pull on the pulleys, the sail still goes up the same distance. It's just changing my direction. Instead of pulling the sail up, I can pull down to get the sail up. So if I have a sail, here are my pulleys, and I have a sail that needs to be pulled up. I'm just going to do my best here. And I'm going to make my ropes red so you can see it a little bit better. I have ropes connected to the sail. And I have my person pulling on the ropes. And he's pulling in a downward fashion instead of pulling the sail up the pole. And that's all for this foldable.